Okay, so today we will solve quadratic equations by factoring, by taking square roots, by completing the square. And the first one we're going to concentrate on first, solve by factoring. You got to know what a quadratic equation is. You've seen them a ton. A quadratic equation is one that has an exponent of 2. In order to solve quadratic equations by factoring, you have to understand the zero product property. On the top of your notes, it says A times B equals 0, and then it says IFF, if and only if, either A is 0 or B is 0. In plain English, that says the only way you can get an answer of 0 when you're multiplying is, talk to me, the only way you get an answer of 0 when you're multiplying is
A or B equals 0.
one of the factors has to be 0. Yeah. So, the only way that you can multiply these two things and get an answer of 0 is either one of the factors has to be 0. If I multiply this all out, and you don't need to solve, but I want you to recognize, if I did multiply this out, I would have x squared plus 5x and 2x plus 7x plus 10 equals 0. This is a factored version of a quadratic equation. You don't need to multiply it out in order to use the zero product property, but I want you to recognize that these two factors represent a quadratic equation. And the only way I can get an answer of 0 when I'm multiplying two things and I get an answer of 0, one of the factors has to be 0. So here's what I know. Either x plus 2 equals 0, or x plus 5 equals 0, or both. In this case, x has to be negative 2. Subtract 2 from both sides. If x plus 5 equals 0, then x has to be negative 5. It always kind of amazes me that when I say solve, I will have students say to me, what do you mean solve? Be sure that you know, if I give you instructions that say solve, know that, question?
On the notes, it's actually x minus 5.
Oh, okay. If it's x minus 5, then that makes it negative 5x plus 2x. That'll make it negative 3x in the middle, and last times last, negative 10. So this one's still going to be negative 2, and this one's now going to be positive 5. Thank you. So back to, if I ask you to solve, I'm asking you to find the value of x that you can plug into this equation. So let's take 5, plug it in. 5 squared, 25. Minus 3 times 5, that means 25 minus 15, that's 10. Then 10 minus 10, you get 0. If you plug negative 5 into this equation, it makes it true. What if you plug negative 2 in? Negative 2 times negative 2 is 4. Minus 3 times negative 2, that's
4 plus 6.
that's a negative 3 times negative 2 is positive 6. So we got 4 plus 6, that's 10, minus 10 equals 0. Solve means find two values of x that you can plug into this equation and make it true. We have a fundamental theorem of algebra that says if you have an equation to solve and it's got an exponent of 2, if it's degree 2, then you can find two solutions for it. The next one, the zero product property. I've got these two things multiplied. Actually, it's a quadratic equation that's in disguise. If I multiply this out, I'll get 6x squared minus 9x plus 10x. So that gives me plus 1x minus 15 equals 0. You don't have to multiply it out in order to solve it, but I just wanted you to recognize this factorization represents a quadratic equation. And in a minute, when it says solve by factoring, we're going to start here and get to here. This one's already a gift. It's given to us in factored form. That means the only way I can get an answer of 0 by multiplying these two things is either 3x plus 5 has to equal 0, or 2x minus 3 has to equal 0. If 3x plus 5 equals 0, this is now just a linear equation to solve. So subtract 5 from both sides. That means 3x equals negative 5, and divide both sides by 3. One solution is x equals negative 5/3, and the other one, add 3, divide by 2. 2x equals 3, and x equals 3 halves. if you store -5/3 as x in your calculator using that store button, and then you type 6x squared plus x minus 15, enter, it better give you 0. Okay? So you found two solutions of a quadratic equation that was already given to you in its factored form. These next four examples say solve by factoring. We're looking for values of x that I can plug in. I want to know what values of x can I plug into this equation that will make it equal 0. Because I know that it's quadratic, I can expect two solutions. So we got to go back and remember factoring. Step 1, is there a greatest common factor? Step 2, count terms. 3. First thing we check for, is it a perfect square trinomial? It's not, because nothing negative is ever a perfect square. Then it's trial and error. At least it's the easier kind, because we have a 1 on the front. So we know that we are going to multiply x times x in order to get x squared. And the thing we've got to worry about is what multiplies to be -27 and adds to be -6. What do you see? One of them has to be negative, so it'll have to be -9, +3 equals 0. So I replace the quadratic equation with two factors, which now means I get to use the zero product property. If these two things multiply to be 0, the only way that can happen is one of them has to be 0, or both. Either x minus 9 equals 0, or x plus 3 equals 0, or both. So you can see what are the solutions. Add 9, x equals 9. 9 is a number that I can plug into that equation and make it true, make it equal 0. -3 is also a number that we can plug into that equation and make it equal 0. On the next one, solve by factoring. We're trying to replace the left side with the factored version of itself. I notice greatest common factor? No. Count terms? 2. If we have two terms, the first thing we look for is a difference of two squares. Are these perfect squares? Then you just have to study, practice, memorize, know that in order to end up with a difference of two squares, you have to multiply, what are they called? Conjugates. So 2x plus 5 times 2x minus 5. And the zero product property says if these two factors multiply to equal 0, the only way that happens is 2x plus 5 is 0, or 2x minus 5 is 0. If we subtract 5 from both sides, 2x equals -5, x equals -5 halves. If we add 5 to both sides, 2x equals +5, x equals +5 halves. So we found two values of x that we could plug into this equation that will cause it to equal 0. On example 3, you can't use the zero product property unless your equation first equals 0. So the very first thing you want to do on this one is subtract 7x and subtract 15 from both sides. 2x squared minus 7x minus 15 equals 0. Now replace the left side with its factored form. There's no greatest common factor. It's got 3 terms. It's not a perfect square trinomial, and the leading coefficient is a 2 instead of a 1. So it's trial and error, the harder kind, where we have to find things that multiply to be -30 and add to be -7. Do you see it? One's got to be negative. -10 times 3. So replace, on these we split the middle. If we replace -7x using these two numbers, it looks like this. 2x squared minus 10x plus 3x minus 15 equals 0. Then group. If we group those two, we can take out a 2x and have left x minus 5. And if we group these two, we can take out a 3, which also means x minus 5. It's not factored yet, remember, because there's still a plus. So these are terms. But x minus 5 is common. So if you factor out a common factor, you take out x minus 5 from both terms. Then that leaves us with 2x plus 3. Double check it, make sure we factored it correctly. 2x squared, we got that. 3x minus 10x gives negative 7x. Last times last, negative times positive, that does give negative 15. Check it. So now we get to take advantage of the zero product property that says if two things multiply to give an answer of 0, one of them has to be 0. So we know either x minus 5 equals 0 or 2x plus 3 equals 0. In this case, x equals 5. In this case, if we subtract 3, 2x equals negative 3, and divide by 2, x equals negative 3 halves. On example 4, is there a greatest common factor? That's the thing you always look for first. 5 is common if we take it out. That leaves x squared minus 4. And then, does it factor again? What's the difference of 2 squares, isn't it? Conjugates. If we factor it completely, we'll have 5 times x plus 2 times x minus 2. Now I've got 3 factors, 1, 2, 3 that multiply to equal 0. Can 5 ever turn into 0? No way, so you don't worry about the 5. So really, only 2 of the 3 factors can be 0. Here's what you know. Either x plus 2 has to equal 0, or x minus 2 has to equal 0. So we find 2 solutions. X is either negative 2, or x is positive 2. Are you okay? Or did I miscopy this problem? I did, didn't I? Write that down as an extra one. Here's the problem that was on your notes. On number 4 on your notes, it was 5x squared minus 20x equals 0. So let's do this one also.
We don't have that.
Yeah, we don't have a number 4.
You don't have a number 4?
No, we just have the 3, and then it starts with square root.
Oh, okay, well add these 2. We'll call this one number 4, and this one can be number 5. And you got a couple extra examples here. What about on this one? On this one, if you factor out the greatest common factor of 5x, then that leaves x minus 4. And this time we have 2 factors. If these 2 things multiply to be 0, either 5x equals 0 or x minus 4 equals 0. What if 5x equals 0? What's x?
0.
For some reason, I don't know why, I always have students who don't like to get an answer of 0, but if you think about it, does 0 work if you plug it in? 5 times 0 squared, that's 0. Minus 20 times 0, that's 0. 0 minus 0 gives you 0. It works. The other thing that you could plug in is 4. 5 times 4 is 20. Times 4 minus 4, 20 times 0 is 0. Both of those work. Okay? So you've got a couple of extra ones, a couple of extra examples on that one. Ashley, will you stop that for a minute?
Mm-hmm.